Alright, so today we're in the polynomial section, the sixth set of notes, and we're talking about division, and this is our second day in the same set of notes. So we're going to be starting on the back side of the first page of notes. So the directions say determine the remainder in terms of A. So notice we're still going to do synthetic division, but now I've removed the number, and our factor says x minus A, so I don't have an actual value. We have a variable, but the idea, the way we go about this problem is the same. So just like we talked about yesterday, the value that goes inside the boxes are 0. So if I were to set this binomial equal to 0 and solve for x, I would get a positive A. As far as our coefficients, I have 1x squared, I have negative 7x, and I have a positive 4. So we talked about yesterday that you drop your first term, and then we go through this series of multiply, add, and so on. So 1 times A is A. Now when I add straight down, they're not like terms, so I'm going to say that this is A minus 7. And now I have to multiply by A, so when I distribute A, I'll get A squared minus 7A. And then I have to combine like terms again, or add, and I can't, there's no terms to combine, so I just add straight down. And for the remainder spot, I'll get A squared minus 7A plus 4. And we talked about yesterday that whatever's in your last spot represents your remainder. So if the question is asking for our remainder, we would say that this right here, this value represents our remainder. So letter B is just like letter A. So you can go ahead and pause the video to try that one. When you're ready, hit play, and we're going to try letter C. So again, letter C. Now they're going to ask you for the value of the remainder again, but now we're going to use K's instead of A's. Notice I have the binomial value. What I don't know is our coefficients. So if I set our binomial equal to 0, the value that I'm dividing by is a positive 2. And now we're going to go through and write our coefficients. So remember, your coefficients are coming from what's in front of each term. So when I look in front of x squared, I have k squared x squareds. So my coefficient of x squared is k squared. My coefficient of x is 4k. And my constant term is negative 8. So again, we're going to go through that whole idea of multiply, add, multiply, add. So it's very similar to the last one in the fact that I still have variables and I can't combine every term, but now the variables are just located in the coefficient spot. So I'll drop my k squared. 2 times k squared will become 2k squared. When I add straight down, I'll get 2k squared plus 4k. So, whoops, sorry. Can't combine them because they're not like terms. Now I'm going to multiply them by 2. So up here I'll get 4k squared plus 8k. And now I add, and I'll get 4k squared plus 8k minus 8. And the whole purpose of doing these problems is to be able to identify what is in our remainder. So this value right here represents our remainder because that's the last value of the problem. So our remainder would be 4k squared plus 8k minus 8. So again, take a moment, pause the video. I would like you to try letter D. Letter D is just like letter C. Alright, so moving down to the bottom of the page, it says determine A such that x minus A is a factor. So if I want this binomial of x minus A to be a factor, that means I want the problem to be divisible. And if the problem is divisible, that means there is no remainder. My remainder would be 0. So now we're going to take that last concept that we just did, and now when we figure out what goes in the remainder spot, I'm going to set that equal to 0 and figure out what values would give me 0. So in our box, again, I'll set this equal to 0, and I solve for x. So positive A goes in our box. I have a 1x squared. I have negative 6x's. And 8 is my constant. And remember, so I drop the 1 and I multiply. Can't add these, so when I put them together, I just have a minus 6. Multiply again, so I get a squared minus 6a. And then I add, so I'll get a squared minus 6a plus 8. And now, if I want to make this problem be factorable, or not have a remainder, I need to say, okay, well, whatever is in my remainder spot, which is this right here, has to be equal to 0. And we know we've done this for quite some time now. To solve a problem to this effect, I have to factor. So our combination that multiplies to be 8 and adds to be a negative 6 is going to be a negative 4 and a negative 2. So if you do the box, go ahead and fill that in the box. If you don't do the box, I'll do that real quick. So I have a squared minus 4a minus 2a minus 8. And we group our first two and our last two. I can take an a out of this. I can take a negative 2 out here. Sorry, that should be a plus, which makes this a minus. And then it factors down to be a minus 2 and a minus 4. And the whole purpose of doing this is to solve. So my two answers I get would be 2 and 4. So that means if I were to go back to this problem and I divided this problem by x minus 2 or x minus 4, I would get no remainder. If I did it any other value in the whole free world, I would get a remainder. So go ahead and try letter B. When you're ready, hit play, and I have one last example for you. So this is kind of like the culminating problem of the whole worksheet. This is the ultimate goal. So this is, again, a problem that you would see on the PARC or a problem that you would see on the SATs when you go to take those. So we're going to take all those skills that we just practiced and now apply it to the most difficult problem you would see. So it says, if k is a constant, what is the value of k such that the polynomial is divisible? And again, when it says the polynomial is divisible, that is implying that it goes in evenly, which means it has no remainder. So the first thing we need to figure out is what's in the remainder spot so that I can solve. So we're going to fill in a 1, because again, if I set this equal to 0, then we get a positive 1. And now we fill in our leading coefficients. So notice my highest exponent is cubed, and I have k squared x cubes. Notice going down the line, I'm missing the squared term, so I need to use a 0, which is a placeholder that will kind of skip over the squared term because I'm missing that. Then I have my regular x term, and I have negative 6k x's. And lastly, I have a constant of 9. So I drop my first term, and I multiply, and that's where the k squared comes from. I add straight down, and I get k squared. 1 times k squared is k squared. Add straight down, I get k squared minus 6k. Multiply, I get k squared minus 6k. And now down here, I'm going to get k squared minus 6k plus 9. So notice this is in the remainder spot, this trinomial. So I need to take this trinomial and set it equal to 0 so I can determine the values of k. So I'm going to flip the screen so I have some more room, and then I'll come back to this screen. So I had k squared minus 6k plus 9. And I know my two values that will suffice this information would be a negative 3 and a negative 3. So whether you do the box method or this grouping method, go ahead and factor this. I'll do the box for this one. So I have k squared I have 9, I have negative 3k, and a negative 3k. And now I find the outside, so this will be a k and a k, and this will be negative 3 and a negative 3. So this factors down to be the quantity of k minus 3 squared. So you might have written out k minus 3, k minus 3. Since there's 2 of them, I condense it and say it's squared. If I wanted to solve this, I would take the square root, and we know the square root of 0 is just 0. And I'll add the 3 over, so k equals 3. So if my k value is 3, and I plugged it in, that means the problem would now be divisible. So let me go back a slide. So if k was 3, this problem would say, if I plugged in 3 everywhere, this problem would say 9x cubed minus 18x and plus 9. So if I divided it by x minus 1 using synthetic, I would get no remainder. So that's all for today. We'll pick up with this tomorrow.